In this lesson, we explore the process of creating textured 3D terrains using various kinds of elevation data processed with the GIS software QGIS. This 3D data can come from LiDAR, SRTM, and other similar places. You can find links in the description to my other videos that explore processing these data. This is useful if you want to illustrate an area, such as an archaeological site, in 3 dimensions, or perhaps build the ground surface for an interactive digital product hosted via Sketchfab or some other platform. This tutorial will use 2 open source programs, QGIS and Blender. We will begin by gathering and visualizing our data before creating a shapefile to clip our elevation data and a second image to use as a texture. For instance, an aerial photograph, a historical map, or perhaps a different way of visualizing the same elevation data. Next, we clip and export our data for use in Blender. Once imported into Blender, we'll explore a quick way of using the elevation data to create a 3D plane and assigning the second image as the plane's texture. Finally, we'll export the data for use in other applications, like the online 3D content sharing platform Sketchfab. Okay, let's get started. We're going to create a 3D terrain for the site of Poverty Point in northeastern Louisiana. Our data is in the Louisiana statewide LiDAR project website, which we can see here. So just to quickly illustrate how we would zoom to this area, here's the town of Epps, and we can sort of zoom into the area. I find it easier to use the streets layer, and there it is, the Poverty Point National Monument. When we click on this, we get these file download options over here. And so we can use contours, DEM, a digital elevation model, a image that already has the elevation data in a raster data set. And for the purposes of this tutorial, that's not really that important. Now, if you click on this, you'll be given an option to download this file. And what this file is going to have is a series of GIS data sets in it. We're only going to use the CES3 and CES4 here. Those are the southern half of this area. Now I went ahead and used the edited points, the actual LiDAR points, to create my own version of this. And of course there is a download link below that will take you to this zip file. Use that to follow the rest of this tutorial. This is a digital elevation model, a DEM with better resolution. So what we're going to go ahead and do is we need to add this file to QGIS. And we do that just by double clicking, and we can see here, and if we zoom in a bit, we can see the familiar features of Poverty Point. And of course, if you're not familiar with Poverty Point, I've included a video link in the description below. So what we're going to do next is we need to visualize this in different ways. We're going to go ahead and leave this original visualization alone. You might notice when we look at this file that there's this question mark. That means its coordinate system is not defined. I apologize for that, but it's something you'll run into. So let's go ahead and set that. If you're not familiar with QGIS, this uses EPSG codes for the Coordinate Reference System, or the CRS. And we can just type in 26915, and that will give us the coordinate system for this data. If we click OK, this will allow us to project it, and you see it's disappeared. Again, if you're working with data like this, you'll notice that. All we have to do is right click and select zoom to layer, and it comes back. So now what we want to do is duplicate this once, duplicate this twice. We're going to turn off the original, go down here to the bottom one, turn it on, and we're going to select the hillshade visualization technique. And so you can see here the features have popped out and they're very, very visible. We want to go to the one above that and choose a different way of visualizing this. If we choose single band pseudo color, we can add some pretty nifty looking visualizations. We're going to left click the color ramp and choose create new color ramp. Then we're going to choose from the drop down catalog CPT-city, click OK again, and then click on the topography settings. I really like this one that's defined at 151 colors. So if you click OK, we need to actually change that a bit to equal interval, and then type in 151 because that's how many classes we had. There's a lot of values here. We don't see a lot showing up for poverty point, but this visualization is something we're going to use again later. Let's just go ahead and change the opacity to 80, and then you can see these two layers working in tandem to produce a pretty stunning visualization of this really amazing site. So with that, we're now ready to go ahead and start clipping our data. Before we can clip the data or take a subsection of it and export it, we need to create what's called a clip shapefile. It's actually a pretty easy and straightforward process. So what we want to do is we want to choose some aspect of this area that we're going to focus on for our visualization. So the way we can do this first is we can use this measure tool and just sort of get an idea, right? We can see these features here. How long or how big of a square are we going to need to sort of capture them? And we can sort of see here as we move around this measure tool, a 1500 by 1500 meter square is going to do a really good job of capturing the majority of the site. So let's go ahead and close that. Now we need to go up to the layer drop down. We're going to create a new shapefile layer. We're going to give it a name of clip. We're going to go ahead and choose a polygon geometry type. And for the coordinate reference system, we're going to go ahead and use the same one. You can type in 26915 and get UTM zone 15 north in the NAD 83 datum, which is actually my favorite coordinate system. So click OK. Go over here and click on simple fill for the fill color. Let's go ahead and put transparent. We can even turn the stroke width up to 5. That's just going to help us see what we're working on. So before we start editing this, you should go up to View and choose Panels and Advanced Digitizing. This is going to open up a new panel that's going to help us make sure the clip boundary that we produce is exactly 1500 by 1500 meters. So now with clip selected, let's click on the toggle editing. We're going to be creating a polygon, so we want to add a polygon. We can sort of start right around here. If you click like I do and you see that the advanced digitizing panel doesn't open, go ahead and right click to stop. Come down here to the corner, and you need to set the coordinate reference system for the entire file. And so we'll just enter 26915 so we get the same one. Click OK. Now if I click here, I'll be able to enable these advanced digitizing tools. I'm going to unclick or left click one more time. Now when I click in here, I'll have the degrees and angle. I'm going to set that angle to 0. Sorry, the D stands for distance, so let me go ahead and put 1500. And now I'm locked into creating a line that's 1500 meters long. 90 and 15, so we're measuring now at a 90-degree angle, another 1500 meters. Do that one more time. Click and then right click to finish creating this. Click OK, and we have our clip file there. Now, if it's not exactly where you wanted it to be, you can use this vertex tool. Just drag a selection rectangle, click on any of them, and then you can see we're moving around the selection rectangle. There we go. We've got pretty good selection here. Just click the Save button, stop editing. Let's go ahead and close out these panels that we opened or auto-opened. You can also sort of click anywhere inside to deselect those vertices. And now we're ready to clip and export our data. So when we're going to clip our data, we're going to use a processing tool. So if you don't see this processing toolbox down here, you can go to View, Panels, Processing Toolbox, and that'll display it. And this is a really nifty and quick way to just find the tools because we're looking for clip a raster by a mask layer. And so let's go ahead and turn on our original layer, double click to open this clip raster by mask layer. You'll see it's already selected what you had selected previously. The mask layer is the only possible vector shapefile here. The original source we can select for the CRS, the coordinate reference system, same with the target, we want it to remain the same. I would encourage you to change the X and Y resolution to keep this at a nice resolution for creating the 3D terrain. I use 0.5, that's half a meter basically, meaning each grid will be about 1.5 feet or so by north and south. We want to go ahead and save this to a file. And so let's just go ahead and name this heightmap clip. Click run. That's done, so we can click close. Let's go ahead and turn off all the other original poverty point files, and we can see our height map here. And because we're looking at a smaller area, our layer styling reveals more of the terrain features. We can go ahead and duplicate this a couple more times, and we'll in a moment go back and visualize those. But let's go ahead and with this height map clip selected, right click and choose export save as, because what we're going to do now is export the height map that we'll use in Blender. So we want to do a rendered image. We can leave it as a geotiff. The file name, let's go ahead and call this Blender height map. Click save. Everything else here is okay. We can change the resolution to half just to make it match, and then go ahead and click OK. And you can see it's actually added that file to QGIS as well, and when we turn it on and off, we can see that these are basically the same file. They're just in different formats. So now what we want to do is, before we switch over to Blender, we want to talk about how we would, for instance, export that kind of visualization we created a moment ago. So let's go up here, turn this one to hill shade. We can see that all the features pop out. It's really compelling. Let's do the next one. Let's go ahead and visualize the other duplicate by changing it to single band pseudo color. We're going to create a new color ramp, use the catalog CPT city, OK, topography. We'll go with that wiki 151 value again. Of course, then we have to change this to equal interval and enter 151. And as you can see, we have this really compelling visualization. Let's change the opacity back to 80. And now we can see those two layers working together to produce this really stunning visualization. Now what we're going to have to do is export this image. Now if you've watched my other tutorials, I show how to use the layout manager. I'm going to do it really quickly here, but I've also included a link to that longer tutorial video in the description. Let's go ahead and call this LiDAR Viz. Click OK. Brings us up a blank document. We want to right click, choose those page properties. The size we want to change to custom. I like to keep things sort of the same, so we're going to enter 1500 pixels by 1500 pixels. So this is going to give us a file that's sort of the same exact dimensions we've been working with. Now we of course have to add that map, so we just click this add map. It will auto lock, and we can drag out our map. It'll auto lock to the other corner. Let's go back to the QGIS, and what we're going to do, we just want to make sure we're centered and focused on this clip layer. So right click and click zoom to layer. What that does, we can close out these other things. What that does is it centers us and brings us right to that layer. So when we're here in the layout manager, we can click this button here that says set map extent to match main canvas extent. And basically what that does is it gets us sort of centered. We can use, if we're in this move item content, we can sort of use the control and mouse wheel and kind of zoom in, and we just really want to get it kind of centered. There's going to be these white bars. That's okay, because what you're going to do is once you export this, you'll take it into your graphic or image manipulation program of choice. I like Affinity Photo, but you can use GIMP or Photoshop. And you're going to crop this to just inside that black bar that is our clip. So here we'll export this as an image. I'm just going to go ahead and name this lidarviz.png. It automatically sets it. I'll leave it at 300 dpi. That's a good resolution. Click save. Okay, here we have Blender. Just click anywhere to get rid of the welcome screen. Press A to select the default objects, D to delete. Then we want to save this, so press Control S. Just going to name it Poverty Point. And then we can start adding our terrain. So click Shift A, Mesh to Plane. We're going to press N to bring up our little menu on the left-hand side. We want to make sure Item is selected, and we want to give this dimensions of 1500 by 1500. Press the period sign on your number pad and it disappears because we're dealing in an area that's really much beyond what most people would use Blender for. So we have to go to the view, add another 0 to end, and all of a sudden we're working at a scale that's useful for our landscape. What we now want to do is press Control A and scale. So this, if you go back to item, you can see this is locked in 1,500 meters as the actual scale. So to add that height map or use it to create this terrain, we're going to use a modifier called displace. We're going to add a new texture that we're going to call height map. Coordinates are going to be set to UV. Now we come down and work on the texture properties. We have to select that texture, which of course we named Blender Height Map. Press F3 and search for subdivide. We're going to go ahead and subdivide by 100. Press Tab again, and if we press 1 on the number key, even though it doesn't look like it, we can see that there's something happening here in our file. So let's go ahead and tab again, F3, subdivide again, and I would encourage you to put 2 or 3. I'm going to really ramp this up and go to 5. Press the Enter key. What this is going to do is really subdivide this, and then when we look, we still don't see much going on. But we can do this by pressing the scale Z and say just hit 20. Now we can start to see our features popping out. And so here you can see, right, this is now shot up to 20 meters. What we want to do is we want to have, at least to begin, the height values in this model correct. So to do this, we need to go back to QGIS and look at the height values. And we need to do this not with the Blender height map, right? Because that's just giving us 0 to 255. It's a grayscale image. This height map clip, which has the original in feet values. And so if we bring up our calculator, we can go ahead and see here 160. So we have slightly different values here. 164.879 minus 58.191 equals 106.68. Let's go ahead and round that up to 107 feet. And then we can sort of quickly use here, what's 107 feet? What's that in meters? 32.5. We'll just go ahead and round that up to 33. Come back to Blender, and in that Z value, enter 33 meters. And so we can see here, this is becoming a lot more well-defined. Right click, choose Shade Smooth, and that will really let these features start to pop. We can use a vertical exaggeration. So I would say try like press the S key followed by the Z key and then 1.5. That's a 1.5 vertical exaggeration. It's not extreme. We can press Control Z, maybe do scale, press the S button. On the Z axis, press the Z key. Let's try 3. That's very prominent. It also looks a little unnatural. So typically for me, SZ 1.5 is good. So what we want to do now is just apply this modifier. We do that by clicking this little drop down, apply. And so now what we have is a 3D mesh, a 3D terrain that is locked in. It's real, it's assigned. If I edit it again, it stays with all of its 3D coordinates. We can go ahead and one last time press Control A, scale. So we have everything scaled up here, and that makes sense, right? We have a Z value of real world coordinates or real world measurements of 33 meters, we've exaggerated that a bit just to help us visualize this. Next, I would go ahead and scale the whole thing down. Press the S button, 0.5, maybe do it again, scale 0.5, press the period on the number key. And so what we have now is still a large 3D model, but it's a lot more manageable. And press Control A and scale to lock in those values. And now what we're ready to do is assign the texture. As you can see, I've already cropped it. So we're just going to go ahead and create a new material. We're going to name it, just stay with the same naming convention, LiDAR Viz. And we're going to go ahead and drag this out. And I'm going to set up a shader editor. Press N to get rid of that menu. This is a little easier to work this way. Shift A to search, type in image texture, drag that around, click to lock it in, drag this out from color to color, and then you're going to open the LiDAR Viz, click open image. Should go ahead and tweak some of these other values. I'll drag down the specular. I like to drag out the color and use that for roughness. I bring down sheen tint. I should mention at this point, right, CG Geek video explores how to create 3D terrains with Google Maps in Blender. That's a different workflow, and you're constrained to data available in Google, which includes like specific satellite dates and SRTM data. The CG Geek video is really useful if you want to explore additional methods for working with the textures. So once we've got this set up, we're just going to do a very modest little texture. I can drag this back over here, get into one window, press the Z button, choose Material Preview, and there you go. There's your 3D model. So now we're ready to export this terrain. Now that we've completed creating our 3D terrain, it's a very easy process to go ahead and export this. OBJ, the object format, it's a fairly open format. Create a new Blender, and we can leave it povertypoint.obj, export OBJ. And then of course what we just want to make sure we look at here is in that Blender folder, we have the poverty point OBJ. We also want to make sure that we connect that LiDAR Viz. So I'm just Control-Cing and adding another instance of it here. You can see it's finally finished exporting from Blender. This is not a small file. It's not huge, 50 megs. This NTL file is the material file. And what it does is if you double click on this, I'm on Windows, this should bring up the 3D viewer 3D model. Meaning, right, that this is now in a format that can be read by a lot of other programs. So for instance, if you wanted to upload this model to Sketchfab, you would select all of these files, right click, send them to a compressed or zipped folder. So as always, links to location of data, software, and relevant tutorials are in the description. If you found this tutorial useful, please hit that like button and subscribe to get future updates. Also, feel free to ask questions in the comments. Let me know if you have an interest in another related tutorial using open source software for digital archaeology and heritage. I don't know everything, but if I know how to do something, I'm happy to share that information and share that knowledge.